Chapter 2, Section 2.9 is rounding with significant figures. So if you have a digit following the keeper, and when we say the keeper, it's the number you're trying to decide whether or not to keep the same or round it up. And so if the digit following that number is greater than 5, then you're going to round up. For example, 42.68 grams, if we're trying to decide whether or not to keep the 6 or round it up to a 7, since it's followed by an 8, the 6 will round up to a 7 and we'll have 42.7 as our answer. This is an answer expressed in 3 significant figures, which is what we're rounding all of these answers to. If the number following the keeper is less than 5, then it stays the same. So for example, round this to 3 significant figures. 17.33 is followed by a 2, which is less than 5, so this number will stay a 3, and we'll have 17.3. This is where it gets a little strange when the number is a 5. You have 2 types of 5s. There's a high 5, which is a 5 followed by non-zero numbers. In that case, you're going to go ahead and round up. So here we have 3 significant figures that we want, 2.78. The question is, does this stay an 8 or round up to a 9? It's followed by a 5, which also has more non-zero numbers after it. So this is a high 5. So we're going to go ahead and round the 8 up to a 9. Now, the other option is if you have a dead even 5. So a 5 not followed by non-zero numbers is going to, and preceded by an odd digit, is a dead even 5. So on half the time we're going to round up, half the time is going to stay the same. In this example, 4.63, do we keep the 3? Do we round it up to a 4? It's followed by a dead even 5. So since 3 is an odd number, I'm going to round it up to be an even number, and therefore it becomes a 4. If you have a dead even 5, which is preceded by an even number, it's going to stay the same. So 78.6, and I want to keep the 6 or round it up. It's followed by a dead even 5. Since 6 is already an even number, we're going to keep it the same. It's going to stay a 6 because it's already an even number. So some examples. Round 1.23456 to 2 significant figures. So these are the 2 numbers that I'm trying to decide. I'm going to keep these first 2 significant figures. The question is, does the 2 stay a 2 or round up to a 3? It's followed by a 3, which is less than 5, so we're going to keep it a 2. What happens to the 3, 4, 5, 6? They actually end up becoming zeros. To keep the value of the number, 123,456 will round up to be 120,000. We have to keep the value of our number intact. Try another example. Round this number to 3 significant figures. The question is, does this stay a 6 or round up to be a 7? Since it's followed by a 7, we're going to round it up to be a 7. And then, what happens to my 7, 8, 9? They're going to become zeros to keep the value of my number. So this will be 457,000. Round this number to 2 significant figures. The 0.00 are not significant. However, we have to keep them because they are placeholders. So they will stay, but they are not significant. These are my first 2 significant figures. The question is, does this 2 round up or stay the same? It's followed by a 2, so it's going to stay the same. And then what happens to this section of numbers right here? Because they are trailing after a decimal, we will not change them to zeros. They will simply drop off. And so our answer would be 0.0022. If we were to change those last 4 numbers to zeros, then we would have trailing zeros after a decimal. 1, 2, 3, 4. And this would actually be 6 significant figures, which is not the 2 sig figs that we are being asked to give. So the answer is only 0.0022. So remember, a high 5 is a 5 followed by other non-zero numbers. So here we want to round this to two significant figures. Remember, these zeros are leading and not significant, but we still have to keep them. So we'll have 0.000, and then these are the two numbers I'm trying to decide. Do I round them up or keep them the same? This 7 is followed by a 5, which is also followed by more non-zero numbers. So it's a high 5, which means my 7 will round to be an 8. The 5 and the 1 will drop off, because if we kept them or changed them to zeros, I would have more than two significant figures. So 0.00078. Remember, a dead even 5 is a number followed by only a 5 with no other non-zero numbers following it. If the number is even, keep it. If the number is odd, round it up. So here, round 33,500 to two significant figures. Here's my first two significant figures. Do I keep that a 3 or round it up to a 4? So 3, and then because it's followed by a dead even 5 with no other numbers behind it, I want 3 to round up to be even, so it'll round up to be a 4. Remember, I'm going to change this to a 0, keep these zeros because I have to keep my number intact, the value of my number intact. They are not trailing after a decimal, that's why we don't cancel them. So the answer is 34,000. Round 32,500 to two Sig Figs. This is another dead even 5. So I am going to decide, do I keep this a 2 or round it up to a 3? It's followed by a dead even 5. So I need this to be an even number. It already is an even number, so it will stay at 2. The 5 becomes a 0, and I keep the rest of my zeros to keep the value of my number intact. So 32,000 is the answer. Why do we have the dead even 5 rule? It's to deal with the bias that may occur in measurements in the lab. If we are always rounding up every time there's a 5, then we're going to round up a majority of the time as opposed to stay the same. So by doing this, it kind of divides up how often do we round up, how often does it stay the same, in order to get rid of the bias that may occur in making measurements. Now let's try a few challenging ones. We're going to round 0.00099999 to 3 Sig Figs. Remember, even though these zeros are not significant, we still have to keep them. Now, we want to keep these 3 significant figures. So what happens to this 9? Well, that 9 rounds this 9 up to a 10. So I'll have a 0, and then I'll get a 1 carried forward. 9 plus 1 is 10, so that gets a 0. The 1 carries forward. 9 plus 1 is 10, so we get another 0 here. This 1 carries forward, and now 1 plus 0 is going to equal 0. I'm sorry, 1 plus 0 is going to equal 1. And then I keep my 0.0 in front of that. However, I only want 3 Sig Figs total. And right now I have 1, 2, 3, 4. So I'm going to just get rid of the last 0. And now it'll be 0.0100. Only 3 Sig Figs in my final answer. 99,999 rounded to 2 Sig Figs. So these are the numbers I'm trying to keep. The question is, does that stay in 9 or round up? Well, this 9 is going to end up rounding it up. So we're going to have 0, 0, 0. The 9 rounds this 9 up to a 10. 0 and a 1. 9 plus 1 equals 10 again. So now we have 100,000. However, since I want two significant figures, we're going to write 100,000 but with a line over the first 0. This way, both of these two numbers are significant. The other way you could write the same thing is if you were to write it in scientific notation, which would be 1.0 times 10 to the 1, 2, 3, 4, 5. So both of these would be acceptable, and they both represent having two significant figures. Alright, some practice. So 72.49 rounded to 3 significant figures. So I want to keep those first 3. Does that 4 stay a 4 or round up? Since it's followed by a 9, it's going to round up. So we'll have 72.5. We want 3 significant figures here. Does that 5 stay or round up? It's followed by a 2, so it's going to remain the same, so we have 45.5. Here we need 4 significant figures. 1, 2, 3, 4. This is followed by a dead even 5. 0 will be considered even, so it will remain the same, 120.0. We need 3 sig figs here. This 9 is followed by a dead even 5. That means I need 9 to round up. It's going to round up to equal 10. So we get a 0 and the 1 carries forward. 1 plus 3 is 4, and then we keep the 2. So in order for this to be written with 3 sig figs, I would write 240 with a line over the 0, or 2.40 times 10 to the 2. I need 3 sig figs here. Do we round up the 1 or keep it a 1? And it's followed by a 4, so it's going to remain a 1 because 4 is less than 5. So this will be 28.1. We need 2 sig figs here. That 3 is followed by a dead even 5 because there are no other numbers after it. So I need 3 to be an even number, which is going to round it up to a 4. So we have 64,500. I need 2 sig figs here, so that 9 is going to round up based on this 9. So 9 rounds up to 10. I get a 0 and a 1. 2 plus 1 is 3. Remember, these are not trailing after a decimal, so I have to keep all these zeros to keep the value of my number intact. So we're going to have 300,000, and then we need a line over this 0 to make it significant because we need 2 sig figs. Or you could write it in scientific notation, 3.0 times 10 to the 5. I need 4 sig figs here. Do we round the 2 up or keep it a 2? Based on that 8, we round it up. So we're going to have 92,530. Because remember, we're going to keep this, we're going to make this a 0. This rounds up to a 3, and then I'll keep all the rest of the numbers that are in front. That'll have 4 sig figs for the final answer. I need 3 sig figs here. This is going to be a 0. This is going to be a 0. Based on rounding this number, do I keep it or round it up? It's followed by a high 5, so it rounds up to a 1. And then we have a 3 and a 1 in front. So this is 13,100. I need 3 sig figs here. So does the 4 stay or round up? And because it's followed by an 8, it's going to round up. And the 8 is going to just drop off. So we'll have 2.45 times 10 to the 4. Remember, you have to keep the rest of your scientific notation for your answer to be correct. Number 3, I only need 3 sig figs. And so this doesn't actually round. It just stays because it's followed by a 0. I have to drop off everything trailing after the decimal. And then I need to keep all the zeros that are in front of the decimal. And so this would equal 32,000. And I need a line over that 0 to have 3 sig figs. Or you could write it in scientific notation. 3.20 times 10 to the 4. This answer needs 3 significant figures. So this will be a 0. This will be a 0. That 9 rounds this 9 up to 10. So 0 plus a 1 up here. 1 plus 9 equals 10. Put the 1 up here. 8 plus 1 equals 9. So this equals 90,000. But since I want 3 sig figs, that means I'm going to need a line over the second 0 so that I have 1, 2, 3 significant figures. Or you can write it in scientific notation, 9.00 times 10 to the 4.